This is section 2.3, dividing polynomials and the rational zeros test. The last section we did, section 2.1, we concentrated on quadratics in particular, their graphs, those types of things. Now we are picking up the information we need so that we can move towards solving equations that have a degree higher than 2. So we will be able to solve a polynomial, be able to find all those solutions. We have a lot of little bits of information to pick up and skills to practice before we get there. Okay, so let's just talk about some definitions. A polynomial d of x is a factor of the polynomial f of x if there is a polynomial q of x such that f of x is equal to d of x times q of x. Now, that's a formal definition. We're going to go into it a little bit more here. But basically what this is saying, if a factor, when we talk about it with arithmetic, 5 is a factor of 10 because 5 divides evenly into 10. So if I were just talking about that, then 5 is a factor, and then so because there is a number here that I could put in. The same idea works for polynomials. So if x minus 2 is a factor, I could write it as x minus 2 times something else. Just basic rules of division. So let's look at this formally. The division algorithm. If we have a function and it's divided by a polynomial, so if a polynomial is divided by a polynomial and the polynomial is not 0 because we can't divide by 0, then q of x and r of x are unique, and you can get an answer that looks like this, or you can write it like this, okay, where f of x is equal to d of x times q of x plus r of x. Now, in words, f of x is the dividend. That's what we are dividing. D of x is the divisor. That's what we are dividing into f. Q of x is the quotient, which is generally speaking the answer to a division problem, and r of x is the remainder. Okay, so thinking about numbers, if I did 15 divided by 7, okay, that does not go in evenly. The quotient would be 2, and the remainder would be 1. And that's because I could write 15 as 7 times 2 plus 1. That's all of this is saying. We're just going to be more generalized than we are with the arithmetic. So just like with regular fractions, we do have improper and proper fractions. It's not the actual number value that we talk about. So 1/7 is proper. We're talking about the degrees instead. So if the degree of the top is greater than the degree of the bottom, or thinking about it in arithmetic terms, if the numerator is bigger than the denominator or equal to, so if I'd had 8 over 8, each of these is improper. If the degrees are the same on the top and the bottom, it's improper. If the degree on the top is larger than the bottom, it's improper. Okay? Now, either your remainder is 0 or the degree of the remainder is smaller than the degree that you're dividing by. It's just your remainder should always have a degree smaller than what you're dividing by. We're going to work some examples. Should be very clear. Okay, so let's remind you how to do long division with polynomials. So I have 4x cubed minus 2x squared plus x minus 3 divided by 2x minus 3. When we set up our long division, there are two things we have to check before we actually start working them. We need to make sure that our polynomials are written in descending power order. So starting with your largest exponent, going all the way down to the constant. And then we need to make sure that you didn't skip over any terms. So if I have a third power, I need a second power, a first power, and a constant. And I need to check the top and the bottom. This is a first power and a constant. So you go with your largest, check everything underneath. If you're missing any, you're going to have to put in zeros. I will remind you of all of that. So let's set up the long division because this one is good. So I have 2x minus 3 divided into. Now, experience says I want to write this spaced out a little bit more than I normally would. And that's just because it's easy to get things out of line. It's easy to lose things, and you don't want to make a stupid mistake. Okay. And I'm double checking to make sure I've written it down correctly, and I'm good. So with long division, you want to concentrate on your first terms. So what do I multiply 2x by to get to 4x cubed? Well, I'm going to need to multiply it by a 2 to get the 4. Here I have 1x, I need 3, so I'm going to multiply it by x squared. So I'm going to multiply this. I need to multiply this by a 2x squared in order to get the 4x cubed. Now, I've lined up my square terms here. It's technically not required, but it does help you know when you are done with the whole problem. Okay, so I have this. My next step is to multiply this through here, all of it. So distribute this through this binomial. And that will give me 4x cubed minus 6x squared. Now we want to subtract this away. So I'm going to change the signs on both of these. And your first term should cancel out. And then 4x squared. You definitely want to bring down the next term. I suggest bringing them all down because I've seen a lot of people lose parts of the problem because they don't copy it down. Okay, so now we need to concentrate on the first terms again. I need to turn this 2x into a 4x squared. So to do this, I need to multiply it by a 2 and an x. So plus 2x. Distribute the 2x through here. 4x squared minus 6x. Subtract, so change your signs. Your first term cancels out. I have 7x and bring down the 3. Now one more time. 2x needs to become a 7x. Now the x is taken care of, so I'm just going to be multiplying this by a constant. But I'm going to have to think in fractions right now because I need to multiply 2 by something to get to 7. So 2 times something, let's just call it y since I have x's over here, gives me 7. So that y value has to be 7 halves. So if I multiply, if I put a 7 halves here, and then distribute the 7 halves through this binomial, I get 7x minus, that is 21 halves. Okay, change your signs. This cancels. Get a common denominator and subtract, and we get 15 halves. Now, if you notice, there's no more space up here. The degree here is smaller than the degree here. This has degree 1. A constant has degree 0. So we have our answer here. We're asked to find the quotient and the remainder. The quotient is right up here. And the remainder is right here.